of the linear queue and implementation of the circular queue using array. So this is the implementation of a linear queue using array. So size of the array is fixed. In the linear queue, you can see you have to pass array, and array is passed as the reference. So it is collected as inside A, pointer A. Pointer A holds the base address of the array. So A is the actual array only, which holds the elements of the queue. So a reference of front and rear, pointer to front and rear is passed because we are going to modify front and rear in NQ and DQ. So that's why it is passed as a reference. An item is what item we want to insert into the queue that is passed. So as I stated, if rear is max minus 1, max is maximum size of the queue. If it is max minus 1, it is queue. Else you have to increment the rear by 1 and item is inserted at rear. If it is empty, you have to increment front also. So when it is empty, both front and rear are -1. In that case, you have to make both as 0 because after inserting one element, it is going to have one element. So queue with one element is having front and rear both as 0, pointing to the same index. So that's why if front is -1, front is set to 0. So in DQ, first of all, we need to check whether the queue is empty. So if front is -1, then the queue is empty. So display queue is empty and return null. Else, whatever is the front, that take it in the data and return. Set to 0 and increment front by 1. If front and rear both are same, then it is having only one element. So if the queue is having only one element and that is deleted, so you have to set both front and rear as -1 and finally return the data. So here in this case, 3 elements are added and 3 elements are deleted. So this is how NQ and DQ functions are called. So let us consider now implementation of the queue, linear queue using linked list. So linked list, you know, every structure has node, data and next. Sometimes this is link or sometimes it is next. And inside the queue, you have a 2 pointers. Struct queue, you have the 2 pointers, front and rear. Front is pointing to array of firstly inserted node and rear is pointing to array of lastly inserted node. So in init queue, you have to pass this structure queue, and in init queue, you have to make it empty, and in enqueue, you have to insert one element, and in dequeue, you have to delete element from the queue. So delete all queue means you have to make it empty. So init queue means queue is the structure inside which you are having both front and rear pointer. When both front and rear are set to null, then queue is initialized. Then when you want to insert the element, you have to insert the element at rear. Now let me give an example to you. Now this, whatever program is given over here, its implementation is given. So this is the queue, structure queue. In this you have 2 things, front and rear. Front means it is the pointer to firstly added node and rear is the pointer to lastly added node. Now initially both are null, both are pointer, front and rear both are pointer, both are null, and then queue is empty. Now we want to add one element in the queue when queue is empty. So you allocate the memory. So this is queue using list. This is the linear queue using list. This is linear queue using list. So when one node is added, so allocate the node whose address is present in temp. Now you want to insert this node in the queue. Now in this, when this is going to be the first node, both front and rear point to this node. Both front and rear point to this node. Suppose here the data is 10. Now here it is 0 because this queue is only having one node and this is the first as well as last node, firstly inserted as well as lastly inserted. So suppose its address is 1000. So both front and rear holds 1000. Now suppose you want to add another node. So likewise allocate the node whose address is in the temp. Suppose this node's address is 2000. Now this node is added after this node and rear is pointing to this node. So how to add this node after this node? So this is right now current last node. So it is going to be rear arrow next. So rear arrow next. You will get the last node's next part. In last node's next part, add 2000, which is there in temp. So 2000 is added here. So now this is pointing to this and make this as a null and make rear to point to this node now. Now this is the last node. Make rear to point to this node. So these changes you have to make in enqueue operation. In dequeue operation, when you want to delete the node, the node which is pointed by front, the node which is pointed by front is to be deleted. Now how to delete this? New front will be this. After deleting this node, new front will be this. So new front is nothing but current front arrow next. So this is the logic behind the program. So here enqueue, allocate the node. If it is temp, then queue is full. Temp is null. If then queue is full, means no memory is available. Then queue is full. If memory is available, then store the data in that. Temp arrow data is set to null. Temp arrow next is set to temp arrow data is set to item. Temp arrow next set to null. Then you want to insert that node. If queue arrow front, so front is always pointer inside the queue. So queue is the structure queue. Inside the structure queue, we have two pointers. If queue arrow front is null, means the list, the queue is empty. The queue is empty. Then set both front and rear to temp. Means store the address of new node in both front as well as rear. Because when in empty queue, you store the one node. So both front and rear points to that node. So store the address of that new node in both front and rear. If it is not null, if this queue arrow front is not null, then means queue is not empty. Queue is having one or more number of nodes. So in that situation, store temp new node's address in current rear node. So current rear node is pointed by queue arrow rear. So current rear node is pointed by queue arrow rear. Now you can see it over here. So if you want to add new node, so here this is the temp. Then this is the rear now. This is the rear. Now rear arrow next. Rear arrow next is this. So how to access this? Queue arrow rear arrow next. So queue is the queue is the pointer to the structure. Q is the pointer to system. Q arrow rear will get you this rear, Q arrow rear. Rear means it is pointing to this node. Arrow next. Arrow next means this. Here you store the temp. So this will point to this. So that is what is shown over here. So Q arrow rear, arrow next is set to temp, and Q arrow rear. So new rear will be new node. And make rear to point to this node. So that is what given over here. Make rear to point to this node. So this is implementation of the enqueue in queue using linked list. So dequeue in dequeue, if front is null, then queue is empty. So you cannot delete from empty queue. Then in else part, it is not empty. In else part is not empty. Then take the data in item and then update the front temp, and then make temp to point to front node, make temp to point to front node, and then update the front to second node. Means current whatever is the first node, second node will become the first node now. So Q arrow front is equal to current front node next part, and then free temp and return item. So delete all means it will delete all the nodes. So this is enqueue and dequeue call to insert a node in the queue using linked list, and dequeue is to remove front node from the queue. Now this array implementation already we discussed front and rear. So I will make these programs available on the team. So what already we have discussed the logic of this. So first check it is using array, circular queue using array. Check rear is max -1 and front is 0. This is one condition. Other condition is rear is front +1. Rear is front +1, then queue is also full. So you have to remember these conditions. So in exam, these conditions may be asked. Else if rear is max -1, then you have to update new rear will be 0. So if rear is pointing to last, so current rear is pointing to last node, so you have to make it circular. So after last index, next rear should be 0, and at that index you have to insert the element. Otherwise, now see here. Now see here, this is the condition. This is the rear. So 0, 1, 2, 3, 4, 5. So right now rear is 5. Now here front is here. So these two slots are empty. Now whenever when you want to make it circular, you can insert next element in this slot. So right now there is A, B and C. So only 3 nodes. So if you want to insert D, D can be inserted here. Means after index 5, next index to be inserted is 0. So similarly, rear is 5. So rear is max. Max is 6. So here max is 6 because 6 elements you can store in this. 0, 1, 2, 3, 4, 5, 6. 6 elements you can store in this. So rear is max -1. So rear is 5. Max is 6. So rear is max -1. So after this, new rear will be 0. So same condition is explained over here. So if rear is max minus 1, new rear will be 0, and at that index new item is inserted. Else, if it is not, then it is a straight away rear is incremented by 1 and item is inserted at that position. Now again, the special case is if front is equal to, if front is minus 1. Now see, this is the condition. So this is the condition. See, if front is minus 1 and rear is also minus 1. In that case, Q is empty, even though the size is suppose 5, 0, 1, 2, 3, 4, even though size is 5, the Q is empty. Now you want to insert the node, where you can insert the item here, because it is empty. So first element will get inserted at index 0. So when you insert new element at index 0, both front and rear should point to this. So make front also 0 and rear is also 0. So make front as 0. So rear already, if it is minus 1, it would have made 0 here. If already here, if it is minus 1, then it would have incremented here and it has made 0. But if front is minus 1, you have to make it 0. Same way, delete Q. When you want to delete the Q, when front is minus 1 and rear is also minus 1, then the Q is empty. You cannot delete from the empty Q. Else, there is one element. So that take that front element into the data, because you want to return this data. Front element, take it in the data. And then both front and rear are, then when front and rear both are same, then there is only one element. When both are same, then there is only one element. Now you can see this condition. When both are same, now see, you can see here 3, 4, 5. So it is the queue of 5 elements. So front and rear both are same 0. So here there is only one element, and front is also pointing to the same and rear is also pointing to the same. 0, 1, 2, 3, 4. See, remember, front and rear are indexes. So front is also pointing to the same, rear is also pointing to the same, and you want to delete this element. So there is one element. After deleting this element, both front and rear should become 0. Now consider another possibility. Now you insert, suppose you have 5 elements. So you have 5 elements in the queue. When you initially, when it is empty, then front is minus 1. Just like top is minus 1 in stack, when it is empty, front is also minus 1 and rear is also minus 1. Rear is also minus 1. So in that case, this is empty. Now when you insert A, so A should get inserted at index 0. So make front as 0 as well as the rear is as 0 when it is increment for the first time, and insert A. So insert element at index rear. Now again insert B. Now make rear plus 1. So now rear becomes 1, and at index 1 B will get inserted. Front remains same. Front remains same, but rear is now pointing to this because B is lastly inserted. Now again insert C. Now rear becomes 2, and C gets inserted here, and rear is pointing to this. Now here, now you want to delete two elements. Now delete two elements. So when you perform delete operation, dequeue operation, A should get deleted first. So how to delete A logically? By making this B as a front. So what is the index of B? 1. So store 1 in front. So increment front by 1. So now front is pointing to B. And also delete now, also perform delete operation, dequeue operation. Now B should get deleted. So after deleting B, C should become the next front. So next front is 2. So front will now point to this. Now A and B were there, but right now they are deleted. Physically they are there, but logically they are deleted. Now front is 2 and rear is also 2. Means when both front and rear are same, there is only one element in the queue. Logically, there is only one element in the queue. And when you would want to delete this element in the queue should become empty. Queue will become empty. And how to mark empty of the queue? Make both front and rear as -1. Then and then only the entire queue will become empty. Same code is written over here. So when both front and rear are same, make both front and rear as -1. So now the queue becomes empty. Else if front is max -1, means front is pointing to the last node. Since front is pointing to the last node, since it is a circular, make front to point to next node, 0. Now again see this condition. This condition I give you one example. Now right now, suppose there are 5 elements in the queue. 0, 1, 2, 3, 4. And this is the front. And this is the rear. And these two are empty. These two are empty means A, since it is circular. So A, after A, B was inserted, and after B, C was inserted. And C, this is the rear. Rear is 1. And 2 and 3 are logically empty. Now you want to delete element, means you want to perform delete operation or dequeue operation. A, B, C, these are the 3 elements. And firstly inserted is A because front is pointing to A. So front is pointing to A means A is front element and C is the last element, rear element. So, but it is 4 now. So you cannot increment 4 straightforward. You cannot increment F by 1 now. So when you increment F by 1, now F becomes 5. But we don't want F to become 5. After 4, we want F to become 0. After 4, F should become 0. So here max is 5. So here max is 5 because this is the capacity of the queue, only 5 element. So right now, if front is max -1, so front is 4 and max is 5. So front is max -1. Then after incrementing, make front to be 0. So that condition is given over here. If front is max -1, then make front as 0. Else, if this is not the case, then if it is straightforward, then increment front by 1 and then return data. So this is the implementation of the circular queue using array. Now next, a very important type of queue is the priority queue. Now what is a priority queue? In simple queue, the element to be deleted will be the element which is inserted first. So the element which is firstly inserted will get deleted first. So it is based on the order. So here order we maintain it using front and rear. We maintain the order using front and rear. But here the order we have to mention. In priority queue, we have to mention the priority as well as the order. Now let us see how the priority queue is implemented. So every node is having 3 things: item, priority, and order. Order means when it was inserted. Order means when it's what enter. So order first, when it's having order as 0 means it is inserted first. Likewise. Now here, now priority is here. Priority, less priority number means having more priority. So priority 0 means more priority and so on. Priority 1 means less priority. So 0 is given more priority here. So you have to input priority as well as the order. Now, for example, let me explain. Now, my data is A. My data is A, and now its priority is 2 and its order is 0. This data priority and order means here A will look like A, priority is 2 and order is 0. Next, I want to insert B, whose priority is 0 and order is 1. Priority is 0 and order is 1. Now, 0 priority is more than 2. Means priority 0 is considered as more than 2. Now, it should get inserted before A. So it should get inserted like this. B, priority 0 means it should get inserted before A. That is 0 priority and order is 1. Now here, now third element is having priority 0 and order is 2. Means after 1, order is 2. So here important is given to the less value of priority as well as order. Now where this C should get inserted, whether it should be inserted before B or after B or after A. Now see here, you should insert the element in the queue in such a manner that the highest priority element should come at the front. The highest priority element should be come at the front. Means it should get deleted first. It should get deleted first. Now, priority of A is 2, priority of B is 0, priority of C is 0. Means from A, B, C, B and C has got more priority than A. B and C has got more priority than A. So, but both B and C priority is equal. Priority of B and C is equal. But B order is 1, C order is 2, means B has arrived first. Then C. B has arrived first, then C. So B should remain here and you should add C here after B. C and its priority of C is 0 and order is 2. Likewise. Means you have to sort the element, first insert the element and then sort the queue based on the priority and based on the order. If priority is same, then you have to sort it based on the order. Now, once again, I explain with the help of example. Now, this is the queue. Here you don't have to maintain front and rear. It is very straightforward. This element will always be front and this last element will always be rear. Now here, suppose again A priority is 0, order is 1, B priority is 2, order is 1, and C priority is 0, order is 2. Now first A gets inserted here, whose priority is 0, suppose inserted A and order is 1. Then when you insert B, B is inserted straightforward and then sort it as per the order, as per the priority and order. So when you sort B, B will come here after A based on the priority. So after 0, it comes 2. and order, this remains same. First sort based on priority. If priority is found to be same, then sort based on order. Now first see insert here at this position. Then sort these three elements based on the priority and then based on the order. So first sort based on the priority. So if you sort these three based on the priority, so C should come after A because 0 and 0, and B should come after C because its priority is 2. So here, after sorting based on the priority, B will come here and C will come here. So C 0 and 2 and B 2 and 1. B its priority is 2 and its order is 1. Right? Now suppose again you want to insert D, item D, whose priority is also 0 and order is also 2. Order is also 2. Now first insert D over here, whose priority is 0 and order is 2. Now this A is priority 0, order is 1. C's priority is 0 and order is 2. Now C's priority is 0, also order is 2. Now D should get inserted after C. D should get inserted after C. If you sort it based on the priority and based on the order. So D will come here after C, 0 priority and order is 2. Why D will not come before C? Because C has arrived first before D. Now D has arrived next. Even though both are arriving same, since C has arrived first, then D, so D will get inserted after C. Now with this will always be front and this will always be rear. Now D is inserted here. So in this way, the insertion NQ operation of the priority queue, in NQ operation of the priority queue, first insert the element at the last and then sort the queue based on the priority, and if the priority is same, sort it based on the order. So same code is written over here. So first check priority queue. If straight away it is equal to max minus 1. If rear is max minus 1, it is full. Then first add increment rear by 1 and add the data here. Data is added at the rear. Then using this for loop, it is sorted. Using this for loop, it is sorted. So see, this first sorting is done based on the priority. And then if priority is also same, if priority is also same, else. If priority is also same, then else. If priority is same, then it is sorted based on the order. So this is NQ. Deletion is very simple. Whichever is the front should get deleted. So front item, get it in T and make point front to, if front and rear both are same, then make it empty. That is front will and rear will become minus 1. Else front is incremented by 1. So deletion is very straightforward in this case. Now see here, when you want to perform the deletion, now delete front, this front will get deleted. Now how to delete the front? Simply make front to point to this element. So front is equal to front plus 1. So again you want to delete, this should be get deleted. See, what is the deletion criteria of the priority queue? The element which is having highest priority and earlier order should get deleted. If priority is also same, then deletion is based on the order. Order means when it has arrived. So after D, if you want to delete, then D should be get deleted. So make front is equal to front plus 1. So deletion in the priority queue is very simple. Simply increment the front by 1. So again make sure that when front and rear both are same, then there is only one element, and after deleting that element, the queue should become empty. Now see the case. Initially the queue is empty. Initially the queue is empty, whose size is 5, and front is -1, and rear is also -1. And suppose you want to insert A, whose priority is 2 and order is 1. So initially A will get inserted over here. Priority is 2, order is 1. So make both front and rear as 0. So front is pointing to the same and rear is also pointing to the same. Now you insert B, whose priority is 0 and order is 1. Now initially B will get inserted over here. Now sort A and B based on the priority. So after sorting, B will come here and A goes here. So B comes here. B comes here after sorting and A goes here, whose order is 2. B comes here and A goes here, whose order is 2. Now here rear is 1. Because rear, there are 2 elements. Rear is pointing to the lastly inserted element and front is pointing to the firstly inserted element. So front is having index of B. So index of B is 0 and rear is having index of A. So index of A is 1. Now when you perform deletion, simply increment front by 1. So after deletion, you simply increment front by 1. So when you make front as 1, front is pointing to this element. Front is pointing to this element, and both front and rear are 1, means both are same, means there is only one element in the queue. And again, when you want to delete this element, the queue should become empty. Now how to make queue empty? By setting both front and rear to -1. So that is the logic explained over here. So when both front and rear are same, make both front and rear as -1. Otherwise increment front by 1 straightforward. So this is the case for deletion of the queue. Now what are the applications of queue? Simple queue as well as priority queue. Now simple queue is used in the job scheduling. So imagine in the lab there is a printer and all the machines are connected to the printer. Now you can give printing from all the machines. So that whatever document you want to give to the print, so that is stored in the queue. And then the document which has arrived first will get printed first. So that is the principle of printing. Let me explain. So here is the printer attached to the LAN to one PC. So this is a PC. This printer is attached to this PC, and this PC is print server. This PC is the print server. So to whatever PC the printer is attached, so whatever server the printer is attached, that is called as print server. And all the machines are connected in the LAN. So first PC, second PC, third PC, and people sitting on these 3 PC give to the document to the printing. So here the person has given a document to print. Here also the person has given document to print. Here the person has given document to print. So what happens in this print server? The queue is maintained. The queue is maintained, and whatever document is given by user 1 first will get stored here. So user 1, then user 2 has given for the printing, user 2, and user 3 has given. So user 3 is stored here. So in this case, first user has given document for the printing, it has come here. Second user has given for document printing, it has come here. And third user has given document for printing, it has come here. Now this print server will pick up this document and give it to the printing. Then print server will pick up this document and give it to the printing, and so on, this document and give it to the printing. So this is how print server works, based on the principle of the document which has given to the printing first will get printed first. Now, second is asynchronous data transfer. Asynchronous data transfer means you transfer the data and leave it. Means it is not assured that whether that data is reached to the destination. So the case of asynchronous and synchronous. Suppose A want to send some to B. So synchronous means when A sends until B responds to A is not assured of that B has A is not assured of that document is reached to B. This is synchronous. Means A sends some message to the B, and then B acknowledges that to A that B has received the message. This is synchronous. In asynchronous, what happens? A sends it on the channel. A sends it on the channel and doesn't wait for the response from B. So in this case, whatever is sent by various sender, A, C, D. A, C, D are the sender. C also sends something on the channel. D also sends something on the channel. They send it and they don't wait for acknowledgement. They simply send it. So this whatever channel they send it on the queue. Whatever is sent by A, it is stored in the queue. Then whatever is sent by C, it is stored in the queue. Whatever sent by this D, it is stored in the queue. And this is delivered. A message A is delivered to receiver. Then message sent by C is delivered to the receiver. Message sent by D is delivered to the receiver. So who does this? Asynchronous server does this job. So here, whenever there is asynchronous communication, there also there is a use of queue. Then call center phone system. So when you call to the call center, your phone is in the queue. Then if that person completes the current call, then whatever call is there in the queue, that is retrieved, and accordingly the calls are attended based on first come first serve mechanism. Then also queue is used in the breadth first search and traversal in the graph. So when we are going to learn graph, there we are going to discuss the breadth first search, how breadth first search and traversal in the graph makes use of queue. Application of circular queue is in traffic light functioning. So it is circular page replacement algorithms is there in the operating systems. So whenever you learn operating system in third year, you will come to know how queue is used in that. Then shortest path tree. So in the shortest path algorithm in the graph and all this thing in priority queues, we are going to discuss in the subsequent chapters. There we will understand the application of the priority queue. Now priority queue is also used in the admission process, your engineering admission process, because you get allotment to the seat. Now say here engineering admission takes place. Now suppose there are 3 seats. There are 3 seats. There are 3 seats, and these 3 seats are filled up based on the merit. So when you submit the application form, suppose for these 3 seats, 5 students have applied. So 5 students have applied for these 3 seats. Now the 5 students application will be stored in the queue. First student merit number is 10. Second student merit number name is A and merit number is 10. Second student name is B, merit number is 2. Third student merit name is C, merit number is 1. Merit number means highest marks. Merit number 1 means highest marks, followed by merit number 2. So merit number and marks are inversely proportional. So more marks means less merit number, as you all know. And then D is having merit number 5, and student E is having merit number 3. Now, first the queue is made. When simple queue is made, A has applied first. So A comes first. Then for after A, B has applied. B comes next. Then C has applied. Then D has applied. And then E has applied. Now this is a simple queue based on the order. So A has applied first, then followed by B, C, D, E. Now you make it, this is a simple queue. Now you make this as a priority queue. So when you make this as a priority queue, this is front and this is rear. So when you make it as a priority queue, the one which is having more priority should come at the beginning. So 1 is having more priority than 2. So this should come at the beginning. So this should come at the beginning. So when you convert this into priority queue, you have to sort this based on the priority number. You have to sort this based on the priority number. Now, after sorting, what queue you get is this. So this will come first. If you sort based on the priority number, C1 and C, followed by 2 and B, followed by 3 and E, followed by 3 and E, then followed by 5 and D, followed by 10 and A. Even though 10 has come first, even though 10 has applied first, if you consider the priority of the A, even A has applied first. If you consider the priority of A, it is 10. So it is having less priority than C, because C merit number is 1 and B merit number is 2. So this is the priority queue. Means simple queue is converted into priority queue. This remains front and this remains rear. This remains rear. Lastly, so here rear means element having less priority and front means element having more priority. And as usual, which element is deleted? The one which is pointed by front. One which is pointed by front. So there are 3 seats. So whom these 3 seats are given? The 3 students having highest merit number. So C is having merit number 1, B is having merit number 2, E is having merit number 3. So this seat is given to C with merit number 1. So now C is deleted. Now next front is B. Then again this B is this seat is given to B whose merit number is 2. Then next front is this as per the merit number. Then third is given to E whose merit number is 3. Now this front is pointing to this. Now these 3 seats are now occupied based on the merit and priority queue by C, B, E. Even though A has applied first, but if you look at the priority, C will get the seat first. C will come out first. So this is how priority queue is used in admission. Priority queue is also used in railway reservation system because ladies quota is there. Whenever there is a quota, for that purpose, priority queue can be used. So otherwise, the arrival, whichever has arrived first, will get first. So if the quota is not considered, the arrival order is considered. So that is the simple queue. If quota is considered, then the quota is given more priority. So in railway, ladies is given more priority. Then even though application reservation separate quota is there for ladies, so they will get a chance. Then senior citizen and other categories are also there in railway reservation system. So wherever there is a merit-based system or quota-based system, there is the possibility where we can use priority queue. So this is all about the second chapter. In second chapter, we have discussed linear queue, circular queue, and priority queue, their applications and their implementations. Now I request all of you to write what are the today's lecture key takeaways.